The top of the LBM-M4 rocket carrying India's prestigious Chandrayaan spacecraft marked a historic moment. In 2023, India made history when Chandrayaan-3 landed on the Moon's south pole, becoming the fourth nation to do so. But what they uncovered has even the renowned physicist who championed space exploration, sounding deeply concerned. Our universe is a three-dimensional bubble expanding in a larger nirvana, never-ending nirvana of 11-dimensional hyperspace. Space is beyond human comprehension, Kaku says. What you do is you send a robot to land on a moon because the moon is stable, no erosion, no rust. The moon then builds a factory. It builds thousands of carbon copies of itself. Unknown materials, strange heat, and possible structures beneath the surface. These findings have the world captivated. Stay with us as we dive deep into this lunar mystery. The stars don't rush their secrets, and neither do we. If you're here for the long journey, Morrow is waiting to subscribe and step into the story. What is Chandrayaan-3? India's lunar mission. Let's start with the foundation. India's Chandrayaan-3, launched by the Indian Space Research Organisation on July 14, 2023, from the Satish Dhawan Space Center achieved a soft landing on the lunar south pole on August 23. This was the first time any nation explored that region up close. The mission followed Chandrayaan-2, which faced a landing setback in 2019, but ISRO's persistence paid off, solidifying India's role in global space exploration. Why the South Pole? The South Pole is a scientific treasure trove. Its permanently shadowed craters hold vast reserves of frozen water, iced leftovers from the solar system's early days, potentially dating back 4.5 billion years. This water could transform lunar bases, offering oxygen, fuel, and hydration for future missions. It's why NASA's Artemis program, alongside efforts from China, Europe, and Russia, has its eyes on this region for permanent outposts. By the end of the decade, Chandrayaan-3's success adds India to that race, proving that the Moon's potential isn't just American or Chinese, it's a global frontier. The mission's designed mission consists of three parts: a propulsion module, a Vikram lander, and a Progyan rover. The propulsion module, orbiting the Moon, carried the spectropolarimetry of habitable planet Earth payload to study Earth's light, gathering data on atmospheric signatures, but Vikram and Progyan did the heavy lifting on the surface. Vikram, standing 2 meters tall and weighing 1,700 kilograms, housed Progyan, a 26 kilograms rover designed to roam and analyze the lunar terrain, packed with advanced tools: laser-induced breakdown spectroscopy, alpha particle X-ray spectrometer, ground-penetrating radar, Chandra's surface thermophysical experiment, and the instrument for lunar seismic activity. They were built to study the Moon's surface composition, temperature, subsurface structure, and seismic activity. The lander and rover operated for 1 lunar day from August 23 to September 2023, sending back data before shutting down due to the lunar night's extreme cold. Scientists hoped for reactivation, but it didn't occur. However, those 10 days of operation delivered game-changing insights: water, ice, minerals, and then something far stranger, a material unlike anything known. ISRO's budget for Chandrayaan-3 was around $75 million, a fraction of NASA's Artemis costs, showcasing India's cost-effective space technology. For global viewers, this efficiency highlights a new player in the moon race, challenging US dominance while offering collaboration potential. The mission's data feeds into international science, including NASA's Lunar Reconnaissance Orbiter, which continues mapping the South Pole. Progyan's onboard instruments, LIBS, and API began analyzing the regolith, the fine, dusty layer covering the Moon. Early results were promising. Sulfur, aluminum, calcium, iron, chromium, titanium, manganese, silicon, and oxygen, all consistent with previous lunar missions like Apollo, Luna, and China's change. But then, something unexpected emerged. Traces of material unlike anything catalogued on Earth, the Moon, or anywhere in our solar system. This substance absorbed electromagnetic radiation in ways no known material could, behaving almost like a sponge for energy, with properties that defied explanation. Michio Kaku, a key voice for theoretical physics and a US-based advocate for space exploration, described this finding as groundbreaking yet deeply unsettling. Why the alarm? If this material formed naturally, it challenges basic physics. Its energy-absorbing properties don't align with any known mineral or compound such as silicates, oxides, or even exotic lunar glasses. It could suggest new chemical processes from the Moon's violent formation 4.5 billion years ago, when asteroid impacts and magma oceans shaped its crust. But its behavior absorbing and potentially manipulating electromagnetic waves doesn't fit. If it's artificial, the question becomes, who or what left it there? Progeon's libs used lasers to vaporize soil samples into plasma, analyzing their light signatures. Meanwhile, APXS fired alpha particles and X-rays to map elements.